Yesterday we talked about multiplying and dividing with scientific notation, and today we're going to be talking about adding and subtracting with scientific notation. So, one thing we need to think about before we start learning adding and subtracting scientific notation is if we were to get a problem that looks like this, 9x plus 3x. If I were to add those together, what would I get? Right, 12x. I add my coefficients and then I throw on the variable at the end. Let's think about something that's 9x plus 3y. Could we add those together? No, we couldn't because the x and the y are different. So when we are adding and subtracting with scientific notation, we need to remember that when we're adding, we need to have like terms. So let's look at our first example. Right here we have 12 times 10 to the 4th power minus 4 times 10 to the 5th power. When we're thinking about scientific notation, what we want to think about when we're adding and subtracting, we're going to make the times 10 to the power is going to be a variable. I'm going to call times 10 to the 4th x. Then I have times 10 to the 5th here. I can't call that x because it's not times 10 to the 4th. So I have y right there. So 12x minus 4y, I can't do that. However, if we think about, we can rearrange our scientific notation. We could adjust and manipulate our scientific notation to help us get x's both here and here. So what I'm going to do, you could do either make this a5 or you can make this a4. You can pick one to do. I want to make this 10 to the 5th power. The way I'm going to do that is if I move my decimal place to the left, then I know my exponent goes up. If I move my decimal to the right, I know my exponent goes down. So I have 12 times 10 to the 4th right here. I have an exponent at the end. I know that if I move my exponent to the left, that my exponent there is going to go up. What's 4 plus 1? Right, 10 to the 5th power minus 4 times 10 to the 5th power. Now what I can do, I pretend like I have an x here and an x here. I have times 10 to the 5th. So now I have to think about what's 1.2 minus 4. What is 1.2 minus 4? This is a great time to pull out your calculator. And you could do 1.2 plus negative 4. Right? I'm going to get negative 2.8. And then, remember, I throw on my x at the end when I have just variables. But let's think about what did our variable x represent in this problem? That's right, times 10 to the 5th power. That is my final answer. It may seem really tricky at first, but don't overthink it. All you have to do is move your decimal so that your exponents are the same in both of your powers of 10. And then you're going to combine the coefficients, either add them or subtract them together. Let me know if you have any questions.